Good afternoon, everyone. Welcome to this Git presentation. Just to let you know that I'm not a Git expert, I'm just a Git user. So I hope this will be your starting point for further uh, research on the topic if you want to use it. Git is just a distributed version control system. There are others in the market, or not in the market but available. So there are some things that are similar, some things that are different. So feel free to look around and search for alternatives or not. So I'm going to talk about the problem we face when we are trying to develop uh, software with other people, or even on our own. Sometimes we get faced with troubles or some days that are not so good or are really bad, and you just want to go back one day and forget whatever happened that day. So I'm going to present you the problem of developing software. How can you use versioning and how can you distribute? Then we are going to talk about the solution, and in this case, the solution presented will be Git. So why version control? When you create your project, first you just put one file, then you add another file, and you put some more files, and everything is tidy and clean and so on. So then you start putting some binaries and images and so on, and suddenly you keep changing your minds and say, well, I don't want this file there. I just want to try with a different file, or I want to remove one file and put another file instead. So, and your folder or your project becomes crowded and with garbage, and then you have those files that you don't want to share with people or with a client or and so on. So things start to get a little messy. And then at some point you're going to start deleting files, but then you say, well, I want to delete this file, but I want to keep it because maybe sometime later on I want to go back at it. Then we start building versions of the directory. So we have my new project becomes my new project underscore old, and I create my new project underscore one. And then I want to do some further changes, and then I do my new project underscore two. And if I go back a couple of weeks ago, then I may need to go to my new project underscore 1A and so on. So there are slight changes on all of them. It's hard to keep up with what changes went into what files and what directories, and suddenly you don't know, you lose your latest version because there is no latest version. There is today's version, then yesterday's version, not really a latest version. And then if you want to share, then you build up your nightmare. Because what version are you going to share? And then when you get back the version from the person you shared with, how are you going to merge it with the one that you already have? So it's really hard to keep track of distributed versions when you are when you have this messy environment. So there is a solution for this, and the solution, the version tracking systems is not new. They are available for as long as the software is built, but there were some difficulties using centralized versions. So the people behind the Linux kernel started developing the Git software uh, version control. So the main difference between the Git and some centralized repository is that you don't take, you don't do versions of files. You do snapshots of your project. And project, I mean your directory where your files, it can be Java, it can be C, C++, images, binary files mixed with XML and so on. So that's your project, your directory. And this version control takes snapshots of your work. It doesn't look on a file per file version. It is a snapshot of what you're doing at the moment. So you have an initial version of your software, and then you want to add up 2 more files to your project. So the version control system, what it does is then it uses the previous version to know that you already have these 4 files on your system. You don't have to replicate them, just need to reference them, and add 2 more files to your database, your version control database. Then you change 2 files, and I illustrated the files with the red dots are the ones that you changed. If you change the files, then you need to store those changes and not change the files that were not changed, because they are not changed, they are already in the database. And any new file that you will insert in your project, again, is also added to the database. If you keep doing changes and, for instance, you remove one file, then you keep reference of any file that was not changed, and all files that were changed need to be marked as being removed. So it's not going to remove it from your database because you want to go back a couple of days ago, or weeks ago, or months ago, and so on, and you still have the file on your database, but not in your working directory anymore. If you keep changing things and adding versions to your version control system, you may want to still remove files, and here in this D version, you notice the place of the file is empty, so the file is no longer in your working directory. Then you remove 2 other files, and those files will be gone in the next version. Well, they will be gone in the current or the latest version on your database, and so on. So this is how Git works. So all files that are untouched, unmodified, they are just referenced to the previous version, so they don't use the space on your system, on your local drive or on your server. But all the other files that are changed are recorded. Those changes are recorded. So with this distributed version, if you then build up a database, then you can share that database, and people can hook up into whatever version of your software they want. They change it, and then what you have to do to merge it is do whatever you would have to do if you just pick up in a different version and try to merge those 2 versions. So when working with a distributed version control, you basically change the content of your files, create new files, you add files, you change them, and you will also download files, which in Git language is you fetch or you pull files from your repository. We are going to look into that in a moment. And then you sometimes have to resolve conflicts. And sometimes conflicts happen when more than one file or one file was changed in 2 versions, and Git cannot disambiguate or determine what is the line that should go into one place instead of the other. Then when you resolve things, you can upload or push things to a repository and then make those changes available to yourself or to others on your project. Distributed version control systems that are well known, you have Git, you have Mercurial, you have Bazaar, and you have some others. I'm going to focus on Git, but many of the concepts are similar or are shared with the other softwares. So Git supports several remote repositories, so you can have more than one repository and you can share, push, and pull stuff between repositories. You have a full copy on your hard drive of the repository. So when you do most of your work with Git, you work locally on your computer. You pull things from the server and then you start working locally. As I mentioned, you have a sequence of project snapshots. So you do snapshots of your project, of your directories, and Git checksums everything. So it will generate an hash key to every file, every directory, everything you commit, every change you commit to your database. And that's how it references the changes by the code of this hash code. You have also three places that you need to be aware of when you are working with Git. It's not location, 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 but it's work, stage, and repository. So three places that you need to be aware that these places are different places, and there are commands that affect one place, not the other, and so on. So, state of file. So your project is composed by files, and it's files that Git tracks. It will take the snapshot of the whole project, but it still needs to reference individual files to see which of the files was changed. So your files can have four possible states. One, it's not tracked, untracked. So Git is, you just let Git know that you don't want it to mess with that file. So there are some files that it can be the executable that your project generates. You don't want to put that in your repository because you just want the source code. It will generate on the fly. It's probably some large library that will be shared or available or from some other source. So there are many reasons for not having some of the files tracked by Git. Those files that are tracked, they have three possible states. They can be committed, so that means that they are in the database and they are not modified. Okay, so committed and unmodified in the literature appears sometimes interchanged. Then you have the modified versions of the file. A file that is in the database and it's changed by you. So you change the file, so the version on your working directory is not the same as in the database. And then you have the staged file. A stage, also called index, in some documents it's referenced as indexed, is a place between your working directory and the database. Everything that you want to go in the database, it has to go through the stage place first. So if you have an untracked file, you first you have the four possible states for files: untracked, staged, modified, and committed. If you want to track a file, you add the file to Git. You do git add, and the file gets added to the staged area. So I mentioned the staged is the place in the middle of the database and your local directory. So you add the file to the staged area, and then you can commit it. When you commit, you are saying to Git, so get my staged screenshot, a snapshot from my stage, and submit it to, sorry, cannot read that.
They are asking you to remove the webcam because it's obstructing the slides.
Okay, fair enough. I told you the webcam was not a good idea. Okay. So I moved forward a couple of slides.
We don't see anything.
Why?
It's black.
Why is it black?
Well, I'm not sure. Maybe it's our connection.
Okay. I'm still streaming, or computer is still streaming. So you take your untracked files, you add it to stage area, then you can commit it to go to the committed area or to the database. once it is in the database, it is also, the file is also on your local directory, and you can change or edit the file just with a text editor, with Eclipse, code blocks, whatever. And whenever you change the file, it gets marked as modified. That means that the version is not the same. You can change the file. If you change it back, to determine if a file is modified, it doesn't use timestamps like previous or some of the version control systems. So it uses hash of the file. So if the hash is the same, then the file is unmodified. So the file is modified. If you're happy with the change, you've done your change, you want to submit it to your database, your change, then you need to add the file to the stage area again, and then you need to commit it again. Okay, so this is a step that's not always clear, because git add and git add have two different meanings here. So git add is being used to register a file, so git can manage it, and git add is also used to say, I want to put this file in the stage area, so next time you do a commit, you actually take a capture of this file. So taking, I don't know if everyone if anyone has installed, has ever installed Git. So Git comes, there is a binary, there's also source code, obviously, but there is a binary that you can download, and it will install a shell for you. If you are on a Mac or on Linux, you already have a decent shell. If you are on Windows, you are better off using this one. And here it is. So this is the shell that comes with Git. It's an OK shell. So what I'm going to do is I'm going to create a directory. So I'm in one directory, so this user is administrator, so I'm in this home directory. I'm just going to do a directory and call it Git webinar. Git webinar. So this is an empty directory. And now I can do a couple of things. One is, if I want to be able to record stuff, Git stuff on this, or to use version control system, I need to initialize the directory so Git can create the structure to maintain all that database. So I used to initialize it, I use git init, and it will initialize an empty Git repository on this directory .git. So if I do now ls -a la, I have here one directory, one single directory on my file, on my directory, project directory, that is called Git. So I'm going to change back to the presentation. Where is the presentation? Nope. This is not the slide I want. So I'm going to initialize the directory so I can use this repository. I'm going to create a file. There is a special file in Git that is called gitignore, .gitignore, that you can write all the stuff that you want Git to ignore and not keep track of. Then there is the command git add that's saying to Git, I want you to register, and I use the dot that is current directory, so I want you to register everything that is in this directory and all the subdirectories. And we are going to do an initial commit. The -m here stands for message, so I'm doing the message, I'm adding a message to this initial commit here. So let's try this. I'm going to just create a file called readme. This is a great readme file. Okay. So I have the readme file, I have the Git file. I'm going to create a project. I could do the whole structure here of the project, but I'm going to use Eclipse to do it. So I'm just going to create a normal Java project file. No Git involved, it's just to use Eclipse to create all those directories that it creates, like .project, ClassPath, bin directory, and so on. So I'm going to call it Git webinar. I'm not going to use the default location. For Eclipse, it's recommended that you use a different directory. If you're using a Git project, don't put it in the workspace. Your workspace is populated with temporary files, and they may mess up with Git, and Git mess up with them. So for Eclipse, it's recommended that the file is put outside. So I already created the file, the directory. So it was called Git webinar, was it? Git webinar. Yep. I'm going to use this file. Yep. Here is the README file. I just added. It is going to create a source file. I'm happy with it. I'm just going to create a class as well. New class. I'm going to call it, let's say, main with project com.example. Finish. So if I go here, I should have. So I have my source, my bin, my README, my project, and so on. And if I go to source, I have com example main. Okay, I'm going to create an empty package here. New, just to illustrate some model. It's empty. Okay, it's an empty directory. Example model. It's an empty directory, and now I'm going to add a new file called gitignore. So vim.gitignore, and in this file I can use several rules to specify what files I want. I can use flags. I can use, so the file can be complex, but can also be just say I just want the bin directory. I think it's called. Let me open a new view and navigator. It's not here. I thought it was bin. I'd say ignore the bin directory. I save it. I'm changing the files on the shell, so I need to refresh the Eclipse so it can view the file here. Here I have gitignore. Open here. So if I go to this directory, here I have the bin. I'm going to put some garbage on bin. Just to illustrate that it's going to ignore the content of that directory. Oh, it already had a com directory. So com example main class. Okay, it was not empty. So now I have my Git and my Git ignore files. Here, my Git maintains all the database. Git ignore just the files that I need to ignore. I'm going to use git add dot just to add everything to my database, and I'm just going to do git commit -m initial commit. So it's telling me now lots of stuff. The first thing is that I don't have this user properly configured for Git, so I don't have an email or an address. It just tried to figure out the address from the domain, from the host name of this machine. So it has this weird email address. You could configure it with these things, or not, but the thing is that it created the database and it added these files. So as you can see, the directory bin is not included here. The git ignore is included here, and the empty directory that I just added here, called model, no, not this one, the source com example model. Okay, this empty directory here is not added as well. So it is not going to add a directory that doesn't have any file. Okay, so it keeps track of files, and directories that have files, they will be tracked as well, but not empty directories. So going back to the presentation. So I just did all this stuff, but now I can do this. I created a project. And now my fellow wants to work on the project as well, and I want to share the project with him. There is a simple way for you to create a new project that is called git clone, and you can see this usually from places like GitHub or Bitbucket and so on. You do a clone of a project, and you can do clones of projects that they are on the disk drive as well. So let's say I going to my home directory, I create a new directory called other webinar. So this is an empty directory. I'm going to clone that file that I had before. Of course, I forgot to know. /c/users, I think it was users administrator. Test webinar. Okay, I better go here, properties. Here it is. Copy. Other webinar, I think it was called. Yep. So I'm going to git clone. Obviously, if I'm going to clone, I don't have the directory is not initialized with a repository, so I don't have a git init here, a .git here. I just going to do git clone and do file column / and then paste not that the place where it used. I believe this shell uses /. let's go to the I think the slashes are all wrong. Yep. So I'm going to mark this one. Other webinar. Right place. So git clone file paste. So I'm going to go to this directory. So it has 3 slashes because the protocol is called file column // the third slash is because it's the root of the file system, C users, and so on. So it's done. It's counting objects, compressed the objects, brought the objects here, and if I check the file, I have a directory called git webinar, and here I have my project with my git, the git ignore, and so on. If I check the readme file, here it is. This is a great readme file. Well, it's readme file. It's not right. So this is how you can create projects from Git. So once you create the project, you just can clone as often as you like. And it's quite easy to clone projects.
Okay, you have two questions. Maybe I can put them.
Yeah, sure.
One answer is if you need to go behind for lots of commits, say 10 to 20, what do you do?
Do you know the hash code for your commit? So if you say you have a graphic interface, so you can browse your commits. If you use servers like GitHub and Bitbucket and so on, you can also access and visualize all your queries or your commits. And every commit has an hash code, and you can refer to a commit as an hash code, and you can say I want to put in my stage directory or in my working directory that version with this hash code, and it will get that hash code on your working directory.
Another question is how does Git work for Mac users?
How does Git work for Mac users? Well, slightly better than it works on Windows for Windows users. I'm a Mac user, so I should put a disclaimer first. So you can use it. Basically, it depends what you use Git for. From the command line, it's similar. As long as you have a decent shell, then it's similar. You just use these commands. If you are using on systems like Eclipse or Xcode or whatever, or tools that have Git already integrated, so you already have the menus usually to do the most common operations like pull, push, commit, and so on. And it's similar for Windows. So the advantage of Mac users is that they have a better shell than Windows users have by default.
I think you've answered this one, but someone is saying, I still wonder if SVN isn't better.
No, there are many reasons why SVN is not better. I don't go into details. Well, but just to resume some of the concepts. So with SVN, you have a centralized repository, and everyone that wants to do a change and make it public has to commit to that repository. Or you can branch as well, but you have always to commit to the server. With Git, you work locally. So all your commits are done on your local hard drive. And then eventually you will push and pull and it will synchronize. but you are working locally, you don't need to be always on. So if you don't have an internet connection, well, tough, I cannot commit things. I have to keep working and lose my track of my checkpoints, if I must say so. And the other reasons why, the other thing that it's much better Git than SVN is for merging purposes. So merged, because merged is performed locally, and each user will merge their own versions and before they push it to the server, it will be easier and faster because you're doing locally than doing it with SVN. So. Okay, any more questions? No? Okay. Now that I've done all this stuff, and you say, well, he's committing things, he's changing places in the file system, and how do I know if things are going well or if things are catastrophically wrong? So let's go back to my previous directory. Well, basically it's the same, but I'm just going to cd webinar. So Git has also some commands to check the status of your files. Let's try to make this larger. So this is what I mean with better shells on Mac than on Windows. Cannot make it larger. So I'm going to use git status, and it will tell me that I have, well, actually I have a README file. This was not supposed to be here. Changes to be committed. I have a new file that I haven't, of course. Why isn't the README file committed? Why is the README file here? Webinar. I think I was in the wrong directory. What is the name of my Git webinar? Okay. That was a test directory, so I should have been removed before I started this presentation. So git status. Okay, this is what I was expecting. So here I have my project, and I have nothing to commit. My working directory is clean. That means that all my files are unmodified. So are the same version that is submitted, that is available in the database, in the Git database. So now I'm going to so this presentation again. So I want to create a new file. If I create a new file, let's say I'll add a license file to my project. New, other, I think don't have license, text file. And I have this license. Okay. And I'll save the file. No. Save. Oops. Sorry. Save this project, and the file is going to be license.txt. Okay. If I go to my shell now, I have the license here, and if I do a git status, it will say, well, this license.txt is untracked. So Git is not keeping track of that file. And just warning me, so I can say, well, what do you want to do with it? Do you want to add it? Do you want to put it in your git ignore file so it doesn't keep track? Or do you want it to be showing this message all the time? So you can decide what you want to do with it. And you can say, okay, I'm going to add the license file. Okay. If I now do a git status, so well, I have changes to be committed, and this file is on the process of being committed. It is in the stage area, is not in the Git yet, so it is in my local stage area, and you can reset the stage area and say, well, I don't want it to be in the stage area, and you can commit it. But now let's say that I come here, this license, this is an MIT license. Oops. So now if I come here and check the Git status, it is this weird thing that says, well, license txt is prepared to be committed, but license txt is untracked. So the reason for this is that the file that I changed before, okay, this file here that is prepared to be committed is that the one that says this is this license, okay. The other one, this one that is not committed is the one that I didn't add to my stage area. So if I commit, this will go into the database. The one that has this is a license file ... and the one that has changed is not in the stage area yet. So I have two options here. I want to keep things like they are. So remember what I just told you in the beginning about snapshots. You do the snapshot when you do the add to a file, not when you do commit. Okay? The add is the one that keeps the snapshot of the file, the records, the snapshots of the file, not the commit. So here you can say, okay, I'm just going to add the file to the staging area. Now if I go to the status, okay, I have one file ready to commit. So here we have a third option for our add command. So the add command can be used to add files to this. Well, it's only adding to the staging area, and as long as you remember that add is adding to the staging area, you're fine. But the thing is that if you have an untracked file, you do add, it will be tracked, but in the staging area. If you have a modified file, you do add, it will be captured a snapshot to the staging area. If it's in the staging area and you do add, it will replace the file that is in the staging area by the new file that is changed. Okay? I hope I did make some sense. But we'll keep going, see if it becomes clear with more examples. So, presentation again. So I do the git status to get the status of the files. That is what I just did. And now we basically I've been showing you how can you add new files. That is with git add. I showed how can you commit tracked files. That is with commit. You must specify a message. So it will generate the hash code for you, but the message is mandatory. If you don't specify one, it will open a text editor for you to put your message. The text editor is configurable, so you can choose. By default, it's probably Vim or something like that. So you can remove files, and you can move files. To remove, to remove files, you just do a git rm file name. And why are you not going just to remove it from your local disk? Well, if you do that, it will, you can try it. I can go here and say rm license. Now if I do git status, it will say, well, I have a deleted file here, and I have it in my database, and it's not on the local computer and on your working directory. So what do you want to do with it? You probably want to, what you want to do is probably git rm and remove it. Or you could say, you do git rm license. Well, no. .txt. I'll try git now. Okay, if I do status, okay, nothing to commit. So git has removed the file from my staging area, so the working directory is clean. But if I want to remove a file, if I do a git rm with the file name, let's create a new file name, need to refresh this one because it's outdated. Okay, so if I go here, I create a new text file, something that makes sense. Yeah, I can go here and can be entitled. Okay. So the file untitled is here. If I do git status, it will say untitled is not being tracked. I can track it. Oh, there is for commit, I think there is an example. This one. This one. You can, if you want to skip adding one file after the other to your staging area, you can use the -a flag. So -a, it will do add to all the files that you already have. So you can do this without having to add all the files. But this will work for tracked files. This untitled is a new file, so I need to add it explicitly. Add untitled git commit -m untitled garbage. Okay, if I come here and I do git status, working directory is clean. If I have the file here, so the file untitled is here. If I remove with git rm untitled, I have a file marked to be deleted. So it's marked now in the staged area. Next commit, it will be deleted. If I do git commit -m and I do untitled gone, git status, everything's fine. And if I do a list of the directory, the file is gone here. So the git rm not only removed it from my stage area, it's still in the database in that version that I committed 2 commits ago, but it's not in my working directory anymore. So obviously, if I want to go back and say I want my current copy to be version whatever, I can do that and the file will pop up again. We'll do that in a bit. Okay, so we are... No more questions? With git, actually there is a bug here. It's not git rm, it's git mv. And with git mv, you can actually do an rm and add files. So it is just moving the file within the git repository. You're just removing from one place and adding it to the other one, to another place. So I'm going to do to check changes. So I can, if I'm changing files, I want to know what things I've changed and not. And I can also want to I also want to check what things have I committed, how many commits did I do, what's the name of the commit I did 10 commits ago, like the question before, and so on. So I can do git diff it will not change anything. because git diff will list changes that I have between my local directory and my staged directory. Okay, so if I now change something, well, this file is gone. So I'm going to put here some system.out.println say hello world. Why not? Okay, so just printing a message. If I come here, so this it will change. It is telling me that file source example main.java has this change here. So these are the changes that I just did. If I do git diff minus minus staged. Oh, it is empty, but this is a way for me to know what is in the stage area being prepared to be committed. So if I now commit this file, so git commit first I need to edit. So if I do git status, it will say this file is modified. You want to edit, you just need to do a git add or do a git commit minus a. It is everything that is being tracked. So everything that I changed that is already being tracked by git, it's going to be added. Minus m for message and hello. If I do a git, this is not what I wanted to do. It's empty now. I'm going to change this. I wanted to put it in the stage not committed. So if I do git status, git add dot status, it's modified. Okay, and if I do git diff stage, it will tell me what is the difference between the stage area and the one that is in the database. So you can check all those changes between working directly in stage area and database or repository. So
there's a question here, I think someone has answered, but maybe you can explain again. Someone is thinking that remove and git remove are the same. So maybe you can explain again the difference.
The difference between just removing from a file system and removing using git.
Yes.
If you remove it from the file system, git it will still be in the staging area, and git will ask you what do you want to do with it, because it is in the staging area, is not in the working directory anymore. So git is not going to remove it from the staging area, and it will keep asking you. You keep adding files, and if you try to commit, it will ask what you want to do with the file, and you usually want to remove it in git as well, because it will remove it from the staging area, and because the commits are snapshots of the staging area, that means that will be removed from that point on, but it's still in the database on the previous version. If you do the remove using git, then you actually are removing the file from the staging area and from your file system. So it will be faster to remove it using git command. So you only have to use one command instead of two. Okay, so now I have checked. No, this is not the slide I was showing. I don't know why is it coming back. Okay, I want to check the logs. If you do a git log, it will show you all the commits that you've done. Okay, by reversed. So the time is the first one is the most recent one. So here you have the message that I just added. Here is the hash code that I've been talking about. So it says commit 140b84 blah 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 blah, and here I have another commit. So I can refer to these commits by these codes. Okay, I can say I want on my directory now to work at this point. Okay, I'm going to show you that in a bit later. So here I have the initial commit, untitled garbage, untitled gone, and so on. You can also let me show it. So we're going up. I want to show you then the graphic tool that comes with Git file system. Where are you? Oh, I actually may have it. Git GUI. Okay, with Git GUI, this one is not open existing repository. I'm going to add the one that is there. It's a previous experiment. So this one is called how is this one? Git webinar. Okay, open, and here I have my repository. I can check my commits. So this is what I have in the unstaged. So files that are modified and are not staged. This one is staged, so I did a commit to this file. So this one will go into the next commit. And I can use a tool that is called git-k. Where is it? Browse master history. Okay, it opened here. Let's try to fit it. So these are all the commits and with all the codes, and I can go here and check what files. Where are the files? View. So these are initial commit. So new file mode should have the initial commit, the hash code. Okay, and here is the path, the tree. Source code. If I go here, you'll have the source code. If I go to the untitled, done, I've gone. So here I have an untitled file. Here it is. And untitled gone, the file is gone. Okay, so it's still in my database. It's not just on my working directory. So here also you can change you can check all the changes and all the files that you've changed. These tools comes with Git. Obviously, there are other clients for Git, and some of them integrated with Eclipse and so on. So moving on with the presentation. Branches. So a branch is a pointer to a snapshot. So the one snapshot of your projects, and by default you have a branch called master. Okay. Then there is this head thing. The head is the pointer to your active branch. So when you first create a project, your head is master, but head can be any other tag or any other branch that you create. The thing with the head is that when you commit to your local repository, the head moves forward. So it creates a new hash code for that directory, for that snapshot, and moves forward to prepare to the next snapshot. So it moves forward to in your staging area. Again, it's blinking. So what did they lose?
Now we're back.
And did they lose a lot?
Well, now you may wait just a little bit because there's an ad. Now I can skip it.
Should I go back to the previous slide, or should I present these slides again?
Maybe that slide again should be.
Okay. So I'm going I'm going to talk about branches. So the way you keep pointers to your snapshots of your code. And so I'm going to represent the commit anatomy, so you can understand later how can you keep records for these snapshots. So a commit object is a pointer to a snapshot of your stage area. So that's the area between your working directory and your Git database. So you put files there, you add, you add files there, either untracked files or modified files, and you just then, when you commit, it will take a snapshot of that, or what's in that area, record the author, the date, a message that go with your commit, and what parents does this commit comes from. If it's the initial commit, it has no parents. A regular commit, to say so, it has one single parent. If you are merging between two parents, then you'll have two or more parents in your commit. So all your files in your project will generate a blob, or modified files will generate a blob with the corresponding hash code. The trees that contain objects also generate an hash code, and actually the directories will generate a tree in your database, in your Git database, with the corresponding hash code, and will be created the initial commit, or not the initial, the commit object, that is an object that has an hash code as well. This is the hash code that you refer to the code that you name the commit, if you can say so. It has an author, it has a message, and it may have parents. So 0 parents for initial commit, one parent for regular commits, and 2 parents for merges. So if you want to record this commit, then let's simplify and say, well, I have commit 9530 blah blah blah, and there are other 16 characters or something or more. And this has no parent. This is my first commit, and it has a snapshot A of my staging area. After this, I do a commit. My parent will be my previous commit, because I'm changing the content of that snapshot with snapshot B. Okay, so this commit will be called 7B5D. Then the third commit, and the parent is the 7B5D. Snapshot C is the one that changes snapshot B, which in turn changes snapshot A. This one is called by default the master. So this is my branch. When I initialize the Git, trying to change to the, if I come here, it says on branch master. So it keeps saying that on branch master, on branch master. So it's easy to remember that I'm working on master, and I'm working on master because that's what head points to. Okay, I can change head and say, well, now I want to work on some other branch. So head will point to some other branch, and the head will be the one that will move forward when I do a commit. So if I commit, say, commit BFOD, obviously parent is DO70, and because head is pointing to master, master will move forward to the new snapshot B. But now let's say that I want to create a branch, and there are many reasons why you want to create a branch. For instance, you say, well, my code, I'm happy with my code, but my client is requesting a new feature. and I don't want to mess up with things as they are now, or I'm going to try a crazy idea, or I'm going to do a bug fix that may take a while, and I don't want to be in the middle of the regular development. So there are many reasons why you want to create a new branch. Let's say I'll do git branch and I'll do a feature F, fit F to fit in the slide. That will be the branch where I'm working on feature F, okay, any feature. And git branch will create that branch for me. But remember, head is pointing to master. So I'm still working on master. If I want to change to feature F, I do a checkout. Okay, git checkout fit F will point head to fit F and not to master. Okay, this is if someone is used to work with SVN, that's a significant difference, because with checkout you basically replace your you just change the branch, but it will take the download the whole new branch from the server to that new branch, while here you're just changing a pointer, so it will be much faster. It is just to change 40 characters string. So now if I do changes and I commit them, it will create a commit, a new commit, which parent is D070, new commit named FL21, and had moved forward with feature, because it was pointing to feature F branch. That is the one that moved forward. And now you can see that master stayed behind. Master did not move forward. So now I have two different versions of my software. I may now want to merge things, and so if master stays behind when I do things, how can I make it keep up or move forward to the branch that I have? Let's first do a different. So I was developing feature F, and now let's say, well, I got a real serious bug, nasty bug, that I must work on now, even regardless of feature F being implemented or not. So feature F is not priority. The priority is the hot fix that I want to implement. So what I'm going to do is I check out master. Okay, so this will take my head from feature F back to master, and then I'll branch hotfix. It will create a branch called hotfix from where my head is. So I want to start from master because commit FO21 is with some weird things for my new feature, so I don't want to mess with that feature. I want to go to the master and branch from there. I check out hotfix. That means that my directory will be with the content of master. And we can I think at this point it may, well, I'll finish. It may be worth to show you what happens here. So let's say that I'm on master and I'm going to git and branch. If I do branch, it will tell me, well, you have master and master only. And the asterisk here in the beginning is telling me what is used by head. So I'm just saying, I'm going to say, I want to branch feature F. Okay, if I do git, I have now two branches, but I'm using master. I do git checkout and feature F. Switch to branch feature F. If I do a branch, see, now I'm working on feature F. Now I'm going to add a new file. I can do it here, whatever. Just going to new. And create a new class, just to could be any file. Feature class. Finish. So I have a new file. If I now do a git status, it should tell me that I have an untracked file. Oh, I didn't commit before, but now I have this untracked file that is this feature class, and I do git add. I do a add dot. Should tell me everything, including this one that has been modified. So now if I do a git status, everything is ready to be committed. If I do a git commit -m, nice feature. Okay. If I do a git status, everything is working fine. If I do a git log, then you see that I've been working. Whoops. I've been working here on a nice feature, and before that it was hello. So it will still show me all my logs for this feature F stream, which will be common to the master feature. So they will share some commits. So now I'm in. Let me see, where is the presentation? So I am now at this point, right? So my head is on this commit here.
There is a question that maybe I think it's on spot. What if I forget to branch before I start making changes? Can I create the branch before I commit?
There are several things you can do. So the question is, because probably not everyone asked the question. What if I do changes and I forget to branch before? So you have a couple of possibilities there. You can stage. You can reset your stage directory, and you can actually there is a special command that is a stash. Well, let me actually, it's not available here, but if you do where is, okay, I was still doing the git stash, this stash command. What it does is resets your stage area. So it will put it as it just forget everything you just added and put all your changes in a temporary directory. Then you could create your branch and you could reload the changes that you just did, that you just stashed away. Okay, that is one possibility. The other possibility would be to commit. Well, no, this was probably the easiest possibility, the easiest thing, the easiest way to do. You can always go back to any version, any previous version.
Someone here suggested is to make a new branch that points to a previous commit. Is it possible?
Yes, because you can check out to a previous version. So you can say, I want to check out, and I want to. So here, when the presentation, you are saying, yeah, here I did branch and I check out feature F, but I could check out any of these codes, previous codes. So I could check out that one and say I branch. The thing was that commit would be already in the master, okay, or in the other branch. So it would not be in your new branch, but you can go back and create a different branch. But that's a different issue than the question before. So you can go back to any point you want. You just need to check out that branch and that commit, and then you can branch from there. Okay. So we were at this point. Let's try to move forward. Let's say now that I want to go to hotfix branch, hotfix. So I want to change something in my files. So something on my project. So I'm going to go to the shell again and say git checkout. Oh, but I wanted to show you something. That is, here I have my project in my source, la source com example feature class. See, I have my feature class here. If I check out to the master, the feature class will be gone, because the feature class was added to the feature F branch, not in the master. In the master, there was no such class. So if I do git checkout, and I do master, I do, in the example, I have my main class, not the feature class. Okay, my working directory is now pointing to the master, and for this master I don't have that class that I just created when I do the feature F. So now I can do hotfix, a hotfix branch, and there is also, instead of creating a branch and then checking out, I can do a checkout immediately, and I say I want a new branch called hotfix. Okay, this is equivalent to generating those two commands, one for creating the branch and the other one for checking out. So switch it to a new branch hotfix. If I do git branch, I have 3 branches now. I have feature F, hotfix, and master, and I'm currently working on feature on hotfix. So let's say that now I'm going to my Eclipse. And now the thing is that Eclipse, I'm using Eclipse just as an editor, and I'm not using the Git tools in Eclipse. And Eclipse is getting a little messed because it says, well, this file doesn't exist anymore because I switched the branches, and Eclipse doesn't know about that. So I'm just going to refresh this, and this should be fine. I'm going to change the main class hello. All right, beautiful worlds. If I now go to the status, git status should say I have a modified file, and I do a git commit -a, because I have a modified file, so the file is being tracked by Git. If I do a -a, it will be added. -m better world. Okay, so git status, okay, working directory screen. So now I'm at this point where I have a hotfix, this one, and master is behind this one. Feature F is also behind this one, and say, well, now I want to merge both because feature F is really nice feature and I want it to have in my project. So how am I going to do it? There is git merge hotfix, and this will merge, actually this one will merge hotfix with your current branch. So first I need to check, I need to do a checkout to master. So I did do a git checkout master, and now I do a git merge hotfix. What this just did was that it will say, well, your master because it's in a straight line from your hotfix, because it's a straight line from master, I can fast forward my master that was running behind to match my current hotfix. Okay, this was in the same line, so it will move forward to match my current. So my head now, I did it on master, so I'm still working on master, but it kept up with hotfix, and this is why it says it moved fast forward to the point where my hotfix point was. But the problem now is that if I'm straight, if it was a straight line from my previous master, it's no longer a straight line from my feature F, because it has a common parent, but if master now is on that branch there, it's not in the same branch as this one. So now I want to check out and merge these two. What I have to do, I want to merge feature F with master. So for that, I want to master now is this one. So this checkout master is just because I could be in any other branch. So I don't have to do it because I'm already on master. Git branch. Yep, I'm already on master, so I don't need to check out master. If I want to merge this one, Git will take into account the common parent. So I could have here a lot of submits, of commits. It will use the parent, the common parent, the one that I want to merge, that is master, with the one that I'm working on, and the one that I want to merge, that is feature F. So if I'm going to git merge and I do feature F, I have a conflict, okay? Because both changed my main.java class. I didn't know they both did. But okay, it's nice that we have a conflict so we can solve the conflict. If they didn't change in the same area, the fix will be done automatically. So if I didn't, by some reason I changed the main file when I close the file, but it will be if all the projects or during the branches you edited different files or different regions of the same file, the merge will be automatically. The thing is that it will be created a new commit file that will be your master branch. The head will still point at master, and the feature F will fall behind, and it will be still on the same node. Because there was a conflict, this node was not created. So we need to merge conflicts, and we need to disambiguate conflicts. So if automatic merge fails, that means that the same part of the file was changed and the merge must be finished manually. There are several ways to do it. There is a tool called git merge tool. It is not configured. Okay. Yes? Another question? Yes.
They are asking, let's say that the feature was still unfinished.
Yes.
Wouldn't it have been possible to apply the hotfix both to master and feature F?
Yes. Yes. You could so the question was if feature wasn't finished, but you would like to take advantage of your master hotfix. Okay. So you could actually be on hotfix and ask to merge while on hotfix, while ask to merge master, and then instead of this one trying to merge there, this will be merged, and you would still be running on feature F. You wouldn't change master. You would create a new commit probably, but that commit would still be on feature F line, and you still be working on feature F. and master will be at this commit point where all your other developers would be happy with. Okay, and also there is another nice feature of Git that is called rebase. It's when you say I want my new feature not to be based on this previous master, but to be based on the master that is further down the line, and then you can rebase that, and Git will apply the difference. So it will put the changes on a side of your, so all your stage area will be put on a temporary directory. You'll move forward your project and then reapply the changes necessary for it to be as you would start the fork or the branch from a later commit. Okay, so the merge tool is not working, but I'm going to open this one, refresh this one. Okay, this is what happens when we have conflicts. So the way Git register conflicts is pretty much the same way SVN and many other version control systems do. So you can still use the same tools, the same conflict tools. So for instance, what it says here is that this is what is in my head. Well, not in my head, in the head of the of my development. Okay, and this is what is in the branch feature. Okay, what do you want? Do you want to keep this one, or do you want to keep this one? And I can go here and say, well, I still want the dots. Okay, so I can have a mix and match of both. Remove this, I remove this. Okay, and once my conflict is solved, I want to tell Git, well, I solved the conflict. And this is another thing where I think Git didn't do a very good job, because to mark things as solved, you use again the command add. So if you do git status, it will say, well, I'm in the middle of a git merge. It's still not finished. The git merge is still not finished, and it's not a good idea to proceed with this being in this unstable state. So some of my working files are not committed. My staged area has files that it cannot disambiguate how to merge. So it's better to solve this or to reset. You can reset and say, well, I go back. I don't want to merge, or if finish the merge before proceeding. So here, if I have conflicts and the file is modified, so say it tells me if I mark the resolution, I should do a head, and that's what I'm going to do. Git add. I have nothing, so I have solved all the conflicts. So I'm just going to do add dot, because I'm too lazy to write the whole path. So if I do git status now, things are ready to be committed, but I still need to commit. If I don't commit, this presentation, where are you? Okay, here. If I don't commit, this file, this one here won't be created. Okay, and this is the one I want to create. That is the one with two parents. Remember that one commit object has one or two parents. If you are merging, you need to have this parent here to be, in order for your merge to be complete. So I do git commit -m merging fit f. Git status. Okay, nothing. Everything is clean. Everything's so now you can. Okay, so no, this one. Yeah, git block. If I go here, you see this merging will have the merge between these two trees, these two parents. Okay, 7B40 and 4F86, blah blah. You can see that these are the beginnings, the initial code of this one here. So this one is here, and this one is this one here. Okay. Okay. I'm not finished yet, and I'm running out of time, but just want you to show you a couple of other features that are important for you to use that are remote. So if up until now I've been working locally, okay, so I've been messing with my own repositories and I've been conflicting with myself and so on. So I want now to be able to share my project with someone else. So Git is something that are the remotes, that are the places where you can pull stuff from or push things to, and you are allowed to have multiple remotes. So why would you want that? It would be something like I have a person that's a project manager, and he may have access to teams of or repositories of several teams in my project, and he may pull and merge things, and he would be the one that would commit to the proper repository. And these repositories, the sub-project and project framework, would be local repositories for these small teams that would work on a larger project. So there are several possibilities how you can configure this. Git just allows you to configure them as any way as you want. So to add a remote, we are just going to add a repository and create one. Let's say we are going to Bitbucket, for instance. Bitbucket. I need to just need to know my password. Problem with passwords. I have okay. Hope this one. Okay, and now it's just going to ask me my password. This is the thing.
We are seeing now.
Yes, because I was hoping that it would log in.
Someone suggests 1, 2, 3, 4.
I should have such a password. Yeah. This is the thing that working with our own computers, we have everything memorized, and then oh, I connected. Did I?
It was 1, 2, 3, 4.
No. Nah. Still. Okay. Okay. Last 10 minutes. Let's wrap this up and open the presentation. what was Git webinar? Git webinar. So we were going to create a file on Bitbucket, or a project on Bitbucket, to upload our wonderful demo project. So I'm going, where is the browser? So I'm going to go to Bitbucket. Okay, so I'm going to create a new repository. It's going to call Git webinar. It can be private, it can be public. So I'm going to create allow forks, so it will be public. Anyone can fork or can create their own copy of the repository. Just a dummy repository. I create, and now I have two options. I'm either starting from scratch, and what Bitbucket will tell me is that I can git init for the file and then git add remote for my project. I actually already did git init, and if you go back, if I go back, the back button doesn't work. Does it work? Okay. If I have an existing project to push up, I can say I cd to that directory. I'm already there. Git branch. I'm on master. Okay, so I want to add a remote. Okay, so what's going to happen here? I'm going to paste. So I'm doing a git remote add. Origin is a nickname or a name that I'm calling my remote server. Okay, Origin is a default name when you are cloning a project from. So if someone else is cloning the project from this repository, it will set the origin. It's a bit like the master is the default branch. The origin is the default remote. Okay, and this URL is the URL for this Bitbucket repository. So I do this, and I now can do git remote. I have an origin here, and I can say, well, git remote show origin. I'll say, well, you want to connect? Yes. And I say, well, there's nothing there. And if you go here, and it will say, well, I'm sad because I haven't pushed anything yet. So I just said to my local repository, you have a remote repository, but you need to push things there. So you need to git push origin origin. So this is you in the beginning of the presentation I said you can have multiple remotes, and I can have a remote that is called John for the remote that John has, a remote for so any other repositories. So I'm going to push origin, and I'm going to push the master branch. So if I do this, it will put everything upstream. If I come here now, what did happen? Could not read what? SSH keys. Okay, I forgot about it. I didn't try that one here. So you need to come here, manage account. I'm not going to push it because we don't have time for that. If you go to your account, you can go to this SSH keys. You generate a key on your computer and you add a key here. Okay, so you do a label here and you paste here. As soon as you do that, then your work will be here and the repository will be there. So this problem is because I don't have writing permissions from this computer to this account. Yeah. So just some more stuff about from the remote. So you can clone a project from its origin. So if you come to, sorry, I'm going to an existing repository, and here I have the SSH address, and I can clone this one. So if I do copy from this address, I can go to any directory. Well, it's not going to work because it's a private repository. I don't have permissions either. But you could go to a directory and you would do git clone, and you would paste the address. Okay, and this one will create a copy. The nice thing, one of the nice things that this will do for you is that the origin of your project, it will be set to the server where you cloned it from. So you then only you don't need to add and remove add remotes anymore. You just, if you pulled it from a server, you just need to push it. If you clone it from a server, you just need to push it or pull it, push to the server or pull to the server from the server. There are a couple of things to keep in mind. So if you fetch from a remote, you just download all the commits that are available on the remote. Okay, they are copied and put on a local database. Your master branch doesn't change. You are still working on the same directory. If you do a pull, besides doing a fetch, it will try to merge the remote, the origin master, so the master that is on the server, with your existing master, or with your existing head, to be more precise. So if it will succeed, your master will be synchronized with the master from the server. So usually, if things go smoothly, you just do a pull. It will pull everything that your teammates push to the server, and you will be all on the same commit of your project. Once you commit your changes locally, you can push them upstreams at any point. Okay, if you are pushing the master, if you are pushing and no one changed the master, the remote master, then the remote master will try to match and will match your local master. So next time someone pull, their master branch will be updated as well. Okay. Okay, so wrapping up, there are tools that will make these things easier for you. Eclipse will come up with eGit. Latest version, it is available in some of the distributions. It is available from the beginning. Others, you have to go there and download it on a separate plugin. Code blocks. There is a suggestion that you can use the Git GUI application and add it as a tool in your code blocks tools. So just to show you briefly the example on Eclipse, if you go with the right click button to team, you can share the project and send it to a Git server. I don't have a Git server now because I don't have credentials to it. But I can. So once I've shared, I didn't share, I just added a remote. I just told Eclipse that this is a Git project. Now in team, I have lots of options. Some of them are to commit. If I do this here, I didn't change any file, so it will say, well, no, this is just to identify myself. you don't have any changes. So did your last message needs to be amended? There was something wrong with your last message? No. Now let's say that I'll do, if I do not save and do a git commit, it will give me some space for me to write the message, and it says, well, this is the message I'm going to add to your commit. So this is going to the project, the file that has been modified and is being tracked and is going to be added to your commit. If you have some other files here that you new untitled text, save, okay, could be this one. If I do a git commit, by default the file is untracked, so you'll see the question mark here. So the file is not tracked. You can check it, it will be tracked, or keep it untracked and it will pop up as untracked all the time. So if I do nice, I do final commit and I do a commit. Okay, now my files, you'll see the orange cylinder that will show you that the file is being tracked. Actually, you can also see that model is not being tracked because it doesn't have any content. Okay, so that is the reason. Then you can push it upstream. This will send your project to your origin server, to your remote, or you can pull it. I'll try to pull it. It's not configured for pull because I don't have permissions and so on. So, but this is, so you pull from the server, you push upstream, and you can browse the remotes as well. So, okay, I think I'm done. Any question? The other one. Is there any question pending?
I don't think so.
No? No, it doesn't show up here. It should show up there. Okay.
Trying to create Bitbucket's account.
Well, you can do with GitHub as well. It's the reason why I used Bitbucket was to show the privacy things, because in GitHub the free account only allows you to do public repositories. Unless you are a student, I think there is a special for students. They can create private repositories, but usually
For them, for these projects.
it doesn't matter. Actually, you can even use a remote server, an SSH server. It's enough. So if they have an SSH server, you can use that as a repository.
There's a question now.
Sorry?
How can I completely remove a commit?
How can I completely remove a commit? Well, you can check out. You can check out to a previous point. Set your head to a previous commit and use from there. You don't really need to remove a commit, but if you really want to do that, you have if it's already in the database, I'm sure there are options for that, but I'm not a Git guru, so I'm just a Git user. You need to Google that answer. But the easiest way is to check out for a previous version and start from there. And just ignore your commit. Oh, and the one thing I left my branches dangling here. So if I git branch, where am I? No, it was git webinar. Git branch. I have 3 branches, and if I do -v, it will tell me it will show me the last commit message for each of the branches, and I can say --merge, and it will show me what commits were merged. And because FitF and hotfix were merged, they appear in this list, and I haven't done anything with them. So it's safe for me to delete them. I just can go here, branch -d feature F, and I delete the branch, and I just delete -d hotfix, and I delete that branch. I'm just deleting the pointers for the names of the branches. So all the nodes are still there, but I don't want to crowd all my, if I don't want to crowd my logs and my console with those names, I can remove them, and they are still there, and they are still on the server as well. Okay? No more questions?
I don't think so.
Everyone disappeared?
Yes,
Okay, thank you very much. I hope you enjoy, and okay. You survived.